Okay, so a cannonball is fired across a flat field at an angle of 60 degrees with an initial speed of 33 meters per second and initial height of 12 meters. So you're supposed to write a set of parametric equations for the motion of the cannonball for the first part. So you know the equation x equals v cosine theta t, and so you know that the velocity is 33 meters per second, and that the angle, which is theta, is cosine 60, and so cosine 60 is a half, so it becomes x equals 33 over 2t. And then you use the second equation, y equals v sine theta t minus 9.8 t squared over 2 plus 12, and you add the plus 12 because there's an initial height of 12 meters. And then you plug in 60 for theta because there's a because that's the angle at when the ball's fired, and then you get this equation. And then I multiplied everything by 2 to get rid of the denominator 2. So then you get this new equation, 33 root 3 t minus 9.8 t squared plus 24. And then you're supposed to determine how long the cannonball was in the air. So I used the quadratic formula and figured out that the ball was in the air for 6.225 seconds. And then you're supposed to determine how far the cannonball traveled in the air. So then you use this equation, x equals 33 over 2t, and you just figured out what t equals, so you plug in t and you get 102.725 meters is how far the cannonball traveled in the air. You're then supposed to determine when the cannonball reached its maximum height. And so I plugged this equation, negative 9.8 t squared plus 33 root 3 t plus 24 into the calculator and graphed it. And then I went second calc and then found the maximum. I just found the maximum. And then so I used the x value of what the calculator told me, and that was 2.916 seconds. So that's when the cannonball reached its maximum height. And then I used the same graph, but I just used the y value that the calculator gave me. So the maximum height reached by the ball is 107.342 meters.